All right, hello everyone, this is Mr. Crozier. I'm going to help you with this practice test. First off, find the limit here. Well, the limit says on day -4, which would be here, what is going on. And this graph is a piecewise function, so we have two pieces, and we have a piece here that we're going to use for the larger numbers and a piece here that we're going to use for the smaller numbers. And you just plug in a -4 to this equation for the large numbers, and it comes out to 15. And you plug in -4 here, and it comes out to -7. So what that means is this graph over here goes up to 15, but over here it goes down to -7. So the limit does not exist. Again, check the left and the right, see if they come together, and they don't. Points of discontinuity are any numbers which cause you to divide by 0. 4 causes you to divide by 0 because 4 times anything is 0. -3 causes you to divide by 0 because -3 times anything is 0. Well, if these are my points of discontinuity, 4 can be factored out. That is removable. So what this means if we were to graph it, let's go ahead and look at this graph right here. If I graph this, and if you have time on your test, definitely take advantage of this. I'm going to graph the numerator, which is x squared plus x minus 20 divided by the denominator, which is two things. It's x minus 4 and x plus 3. And parentheses around the two parts and around the whole thing. Zoom 6 standard. There is at -3, there's this asymptote right here, but then there's a hole at 4. And if I try and calculate the value at 4, it doesn't give me an output because there's a hole right there. There's an asymptote there. There's a hole there. Number 3, the values. Number 1, the limit does not exist. They're going to different parts. -4 from the left side. It's going to infinity. Does not exist. F of 1 is 1. F of -2, undefined. The limit for -4 does not exist. The points don't match. This is going up. This is going here. They're not together. 1 from the right is 1. Value of 2 is 2. There's an infinite number of points there, so if there's not a point and you need one, you can put one there. You just can't put one here or here or here, but everywhere else are points. And 1 from the left side is this way. It's dropping down to -3. Find the limit. Factor out the whole, and now plug in the 3 there. Some fancy factoring here. 1 minus cosine squared is sine squared. Factor out the bottom, it's x squared minus x. And sine squared is really sine times sine. So I have a sine times a sine and a 1 in the numerator. This is the numerator. In the denominator I have x, x, and that term. This is 1, 1, -1 if I plug in 0 there to get that. Just a lot of factoring in here to get it to a point where I have that memorized, and I can direct substitute there. That's memorized, that's direct substitution. Limit. I'm not going to be picky with the wording, but we should get something along the lines of it's an expected value at an input when you're looking at both the left and the right. Factor this. These two parts, the vertical asymptotes are 4, or -4 and 2, and none of them can factor out. So they'll both give me this situation where I have a 0 here but a number here. If you plug in -4, you have -5. You plug in 2, you have 1, but you have a number over 0. And again, let's graph it. Hit y equals x minus 1 divided by x squared plus 2x minus 8. And zoom 6 for standard. Asymptote at -4, asymptote at 2. Horizontal asymptotes, find it to infinity. And again, everything's going to drop off here except this function here. This is what's significant. These are going to go to 0. Divide out the x and I have this. Now plug in infinity. 1 over infinity is 0. And there's the asymptote. And you can see it right there, right? If I draw this horizontal line, I can do this. I'll do it in red here. There's that line and the graph goes closer to it. Zoom a box. Let's do a box and see what's going on over here. let's see what's going on in all this data right here. That graph is getting closer to 0. There's the 0 line. Now if I trace this, watch these y numbers here. These y numbers are going down and down and down. The graph's getting closer to 0. That's an asymptote. And if I zoom it out here, there's an asymptote there and there. Find the horizontal asymptotes there. Find the limit as x goes to negative infinity. Well, we just plug in negative infinity to this one, and we have 2 divided by a negative infinity there. Well, whoops. It's a negative, so it does change it back to positive, which is still just 0. All right, on the bottom one again, a little bit tricky here, but I split this up into 2 parts. This limit over here is fairly simple because it's just a constant function, which is 1/2. This function over here takes a little bit of work. You really don't want to mess with this 3/2. Leave, or that 3x. Leave that alone, but if you multiply by 1.5 and 1.5, now you can pull this constant out to the front, and the bottom becomes 3x. Now, people wondered why we don't multiply this in here, because this is part of this sine function. So don't change this argument right here. Leave this out here. So it's 1.5 times this, which is just 1.5 out there. Now I can find that limit. And that limit is 1. We memorized this limit. And again, if you ever forget what that limit is, simply graph it. Mode should probably be in radians here. And just graph it. Y is equal to sine of 3x divided by 3x. Graph it. What's happening at 0? Well, right there. Let's zoom in on that. Zoom in right there. What's happening on day 0? It's going towards 1. Let's see the value at 1, or the value at 0. It's not defined, but we do see where it's going. If I hit trace, on the left and right, it's about 1. It's about 1 on both of them. All right, this problem has a problem right here at 3. At 3, on day 3, 1, 2, 3, we have an output of 4. But there's this function on the right side that's doing something, and there's a function on the left side that's doing something. So we have to check it. We can't just do 3 because on either side of 3 there's a left and right. So you have to take this 3 and plug it in the left side, get an answer. Plug it in the right side, get an answer. And those don't meet, so the limit doesn't exist. Now when we talk about the number 1, the number 1 is solely on this graph right here. It doesn't fall in any other place in here, so we don't have to check anything else. 1 value is only in here, but the 3, if I'm going left to right, it could be in this one. But if I go left to right of 1, I'm still using this function. Vertical asymptotes, I factor it, and I get -1/2 as a solution, positive -3. These are 2 possibilities, and again, if you can remove it, it's not an asymptote. But as always, take the time to graph it. This is x squared plus 3x divided by 2x squared plus 7x plus 3. Zoom standard. And yeah, right there at -1/2. Let's zoom in a little bit. There's 1, there's 0. At 1/2, there's an asymptote. Horizontal asymptotes. Where is it going to infinity? Only look at the top part, which is just x squared over 2x. These are the highest polynomials. Factor those out. I have 1/2. Plug in infinity. There's nowhere to plug it in. These are numbers, therefore that's my asymptote. And watch if I graph this. 1/2 graph. There's that line. That line is splitting it right down here. It's really hard on these calculators to graph a vertical line, so I can't graph that right now easily, but I can show you there's a line there. The horizontal ones are easy. Jurassic Park. Here's the population. Plug in infinity. 240. 2 plus 4e to the negative infinity. Negative infinity means it's in the denominator. So I take this, put it in here, just like 5 to the negative 2 is the same as 1 over 5 squared. So this negative infinity goes here. Well, 4 divided by infinity is 0. 240 divided by 2 is 120. If you ever have a chance to graph this one is a really neat one to graph. 240 divided by 2 plus 4e negative 0.2x. There. Watch the window on this. Let's go, we can't go into infinity, let's just go out to 20, see what that does. And I think the limit's 120, so I'm going to go up to 150. There's the population. Now what's that population doing? Well, that population is getting closer to 120. There's the 120 line. There's the population line. There's the 120 line. It never crosses that line. Well, let's go out not to 20 days, let's go to 40 days. There's the population, and there's the line. Well, let's go out to 400 days. There's a population, there's a line, and they're pretty much meet right there. If we want to get zoomed in, let's see what this does. Let's zoom in right there. There's population, and there's the asymptote just a little bit above it. All right, number 13. If you plug in 3, you get 3 over 0. Well, that's our definition of an asymptote. There's no limit. And of course, I know some of them are hard to graph. I mean, this one shouldn't be a pain at all to graph. We graph that. Zoom 6 for standard. There it is. And what happens at 3? There's an asymptote. Sketching a graph. Let's make sure these parts exist. Let's see here. There is a limit at at 3. So on day 3, yeah, look at that. There's a limit right there. It's going to there. F of 3 is 1. Input 3, output 1. And it's not continuous. You have to pick up your pencil. It's not continuous. And the limit as we go to negative infinity is negative 2. If I go to negative infinity, my graph keeps touching this line. All right, number 14. The second 14, just multiply by the conjugates, everything cancels out, you're left with 1/2. 15, you can plug that in, gets negative 57. Number 16, find any vertical asymptotes. Well, our only definition of vertical asymptotes is a number over 0, and that cannot be done. Because if you solve this, it would be root negative 3, which is an imaginary number, no real numbers, so no real asymptotes. And again, graph that equation and you will see. How long does it take to graph? Let's see here. X cubed minus 2x squared plus 1 divided by x squared plus 3. Zoom 6. There's my line. Do you see any asymptotes? No. See some crazy stuff. Whoops. We see some crazy stuff here. Let's zoom in here. There's no asymptotes. There's no vertical asymptotes. The end behavior. Well, knock it down. Get rid of all of this to x3 over x squared. Factor it out, and you're left with x. I really recommend you divide by this smaller number here. X over 1, x over 1. So that means, where is this graph going? Well, positive infinity, it's going up. Negative infinity, it's going down. There are none here. There are no vertical asymptotes. Or sorry, horizontal asymptotes. If I draw a line, let's just pick one, 3. That line crosses that line. Every line I pick, 4, 5, 6, 7. Every line I pick, it's not an asymptote. It crosses that line and keeps on going. There is nothing horizontal. The limit on day 3, it's going to 1. The value on day 3 is 2. 4 from the right side is 3. 4. Well, there's no limit. They're not going to the same spot. F of 2, not defined. The limit of 1/2. Well, here's day 1/2, and the value is here. And again, there's an infinite number of points. You can put a point anywhere you want to, except there, or there, or there, or there. Anywhere else, if it's on the graph, there's a point. I said it's about 1.5. And that's just an estimation. 17. If we're going to infinity, we only look at the positive, or the largest, and the largest is 4x squared over x squared. Factor them out as 4, plug in infinity as 4. That's the limit. And what does that mean for a graph? Let's get rid of all these. That means that we have 4x squared plus x minus 7 divided by x squared minus 5x minus 3 graph. And to infinity, way out here, we're going to have to zoom. Let's go further out, zoom out. There's a graph, and there's that line. And now look, if I put that line in there, 4 that we said it was. Yep, there it is. Just had to zoom out a little bit. This graph is going to 4. It's getting closer to that line. All right, last page on the back. Domain. All numbers but 1. You don't have to write it out this way, but learn this notation. X is all numbers, all real numbers, such that, this line means such that x is not 1. Points of discontinuity, -1, and I can remove it. It means there's a hole there. It means if I graph it, there's going to be a hole there. Find the limit, multiply by 2x, do some simplifying down to 1 over 2x, plug in to -4. Difference of squares factor this one again, and now those can factor out. Now you can plug in 2 and you get 32. And the last one, cosine squared. Hopefully you recognize now that is 1 minus sine squared, which is the difference of squares. Factors out, and we're left with this, and now we can plug in the sine of pi over 2 is 1. So that's 6 over 2 is 3. All right, I hope this helps with your work. If you have any questions, I will see you in class tomorrow.